Hi, I'm Paul Battaglia, and this is section 3.1, exponential functions and their graphs. So one of the things I like to do to introduce my students to what an exponential graph looks like is start off with an activity that involves some dice. So I have Gabe and Brittany here that are going to help me demonstrate. So what we're going to do is, Gabe, we're going to start off with you as, let's say, the student that I asked to volunteer.
Okay.
And so we'll give you a die, and what we're telling the class is that we're going to simulate or replicate the spread, perhaps, of a cancerous cell. Okay, so you would represent that cell, and what we're going to do is roll the die looking for a specific number. It's completely arbitrary. You can pick whatever number you like. So let's just suppose that when Gabe rolls a 3, that the cell reproduces. And what that would do is entitle Gabe to call somebody else up from the class and help him roll, and they would get their own die as well. Okay? Every time we roll a number other than 3, we're just going to plot that and keep tracking that there's been no reproduction. Okay? So Gabe, start us off.
All right.
Okay, so Gabe rolls a 2. Nothing really happens other than the fact that we go to the next trial and we still have one cell. So Gabe rolls again. Okay, 2 again. Okay, and perfect, a 3. When this happens, we ask Gabe, hey, who do you want to come up from the class? So
I'll choose Brittany.
All right, good choice. So Brittany gets a die. Now when they roll, okay, what we're looking for again is still the number 3, but we're not going to distinguish. So if anybody rolls a 3, that means however many 3s we roll, that's how many people we call up. Okay, so
let's go ahead.
Okay, so neither of a 3, that's fine. So we're still tracking. Now we have 2 people for the next trial. Okay, and we roll again, and this process continues. Don't be concerned if for some reason the die are not turning up 3s for a while. That's okay. I think it really is a good job of mimicking that slow exponential growth over time. So how about we do it one more time? Okay, so then let's suppose now at this point that after the 4th or 5th roll, now another 3 comes up, okay? So now here I am, I'm going to enter into the equation, and so we'll all roll, same idea, looking for 3s, okay? And so then we would continue this process as we go. Now we didn't get any 3s here. You may have situations where 4 people at a time roll a 3. That's great, 4 more students come up, okay? What I like to do is I like to do it so that all the students are involved. Okay, so if you have a class of 27, let's say, I just have to make sure I have enough die to go around, or people have to share. So it takes a little bit longer, but not a big deal. So once I get the whole class involved, then again, it's your choice. I might even say, let's do it 1 or 2 more times, get some really big numbers. And then after we're done, we sit down, we track the data. Usually what we'll do is I'll do this on the board so that once everybody's involved, they don't have to worry about not being able to keep track for some trials in there. We all go back. We kind of copy the data down. We may even do some regression analysis with it.
Interesting.
Along with that activity, you could also then graph what you found in the data, and then you could show your students that the same transformations apply, finding the domain and range of the functions.
Right, and I think it's good because then in that case they're seeing all those rules we talked about with polynomials and parent functions and all those transformation rules still apply. We're just looking at a new parent, And then I think you could probably even go from there into equations as well.
Yeah.
Again, do you want to talk a little bit about that?
Yeah, do a few equations and also show that the bases aren't always the same.
Correct. I think that's good. And then what do you do when you don't have integer bases? So we're not always going to have 3 to a power or 9 to a power, right? What do you do in cases like that, Gabe?
So here it's probably a good idea to start talking about maybe something like the natural base e.
Okay.
So instead of just introducing e as just a number and sometimes saying, oh, well, this might be the base of some exponential equation, I like to do more of an interactive activity with my students. So something that I like to have them do first is talk about compound interest. So I'll talk about compound interest with my students, share the formula of compounding interest with them, compounding n times per year, that is.
Okay.
So what I'll do from there is I'll say, okay, well, let's imagine we have $1, and I invest this in an account earning 100% interest.
Love it.
I know. I wish I could find an account like that. But anyway, so what I'll have them do is I'll say, okay, well, let's put this in an account for 1 year. After 1 year, compounded once, how much is it worth? Compounded twice, how much is it worth? And then we'll go on, talk maybe monthly,
how far will you take
weekly,
it out?
Daily.
Okay.
I'll maybe
so really
even
getting
take
them to see
a
lot of compound.
And then from there, maybe even every second.
Okay.
And then maybe 10 times a second.
Okay.
And what I introduce here is I say, well, what we're seeing is that this amount of money that we have, it isn't growing huge.
Right.
We're not going to have $10 million at the end of 1 year.
Right.
We're only going to have a pretty small number. And what I'll share with them, the more times you compound the interest, well, you're not really growing exponentially, you keep getting closer and closer to this one number. And what that number is the natural base e.
Right. And I think that's great too, because they don't even realize the whole time that they're doing like a limiting process. So there's that calculus strand in there.
Yeah.
And even that ties in with other things we've talked about in the course, and behavior, things like that. So all along they have these very small pillars of calculus that are being developed inside of them. And that's another great activity. And you can see in section 3.1, we have all these different things for students to do hands-on learning. And so a lot of the discovery is coming from them and from within them, and we're just kind of letting them do their thing, Though I think the one last thing I would finish up with is say, not everything in the world grows exponentially. Some things decay. And a lot of times they've heard the term, but maybe they don't have anything to associate with it. So we have some great examples in the text: radioactive decay. If you don't like that, you can do population decline with species, things like that. And I think once you do that and you've given them an idea of all the different things that happen exponentially, I think it sets the tone now to go into future sections, properties and things of that sort. So I hope these tips have been helpful, and that you have much success in section 3.1.